welcome back from spring break. So listen, if you missed something in class today, you're watching this video. If you were absent in class today, you're going to be watching this video. But basically, the first assignment today is whether or not you're paying attention, whether or not you're following along. And so this is going to be the easiest 10 points you ever made. When you're watching the video, make sure that you're typing things in or writing things down and sending in a picture. Just kind of as proof that you did what we did, okay? So in Canvas, your favorite place, right? If you go into those modules, you'll see this under today's date. So Monday, April 5th, or Tuesday, April 6th. But this is the Simplifying Radicals notes. This is what I'm actually going to go over with you right now. And so again, this will be the easiest 10 points ever, okay? When you click on it, it's going to ask you to put it into a new window, but this is what should pop up, okay? This little surfer guy. Whenever I see the word radicals, I think radical dude, and I think of someone surfing. So you'll have to forgive all the little surfing people. But basically what we're doing is getting ourselves ready for when we do special rights, triangles, and trigs. I don't know if you remember before we left for spring break, we did some trig stuff. And so we're going to have some special right triangles, and there's going to be some radicals involved. So we just need to practice how to simplify them before we get going, okay? So let's go take a look at how it works. So here we are, we're going to simplify some radicals. Basically what you're going to do, there's two different ways to do it, and I'm going to show you how those work. But if you look at the square root of 80, okay, you want to try to find in 80 a perfect square that's going to divide into it nicely. And so for example, the square root of 80 is going to break down to a 16 and 5. And since you know what the square root of 16 is, which is 4, then you write it as 4 root 5. Now keep in mind I want exact answers, no decimals. So this is how you simplify the radical. You have to break the radical down and write it in simplified form, okay? If we take a look over at the green one, right, the square root of 8, again, you're looking for perfect squares. So 4, 9, 16, 25, 36, 49, those kinds of numbers, okay? So the square root of 8 becomes the square root of 4 times 2, and since the square root of 4 is 2, that's what you write, 2 root 2. 20, the square root of 20 is going to break down to a 4 and a 5, and so the square root of 4 is going to be 2, and so you get 2 root 5. The square root of 32 is going to be a 16 root 2, which is a 4 root 2. Square root of 25, right, is, or 75, excuse me, is 25 and 3. Square root of 25 is 5. There's something, though, that I wanted to show you, and that is with the square root of 32. So let me go show you something really quick. Keep in mind, the square root of 32, simplified all the way, okay, is 4 root 2. So here's what can happen with radicals, okay? So the square root of 32 is supposed to be 4 root 2. But you can also write the square root of 32 as 4 times 8, because 4 times 8 is 32, right? So you can also do it that way, but check this out. The square root of 4 is 2, and then you're left with 2 times root 8, and that is not what this answer is up here. And so it can be a little challenging when you go to simplify these if you're going to be looking for perfect squares, okay? So one of the things that you can do is you can do it a little bit differently. And so that's what I'm going to show you. That's what I showed everybody today during class. So that's what this little video is going to be, okay? Some of you are going to be really good at finding these numbers, okay? And some of you are not, okay? So let's go take a look. Slide number 3, okay? So here is an example of the square root of 48. There's 2 different ways you can go about it, okay? The square root of 48, you can break it down to a 16 and 3. The square root of 16 is 4, okay? But what if you didn't get that 16, right? Or you can't think of the 16. So the other thing you can do is you can make a factor tree. So you did factor trees like way, way back long ago, like 5th grade, 6th grade math, okay? But you can do a factor tree. So when you break 48 down, you end up with 1, 2, 3, 4 2s and a 3. Okay, so if you did a factor tree, that's what you're going to end up with. And then look at this. Pairs of numbers go together. So the 2 2s becomes a 4. Those 2 2s becomes another 4. Okay, the square root of 4 is 2. This square root of 4 is a 2. That 2 and 2 makes a 4. on the outside. So that's the other way that you can go about doing it. Let's go look at some other examples, okay? So the square root of 9 obviously is 3, but here's what it looks like if you did a factor tree. So 3 and 3, the two pairs go together, right? Square root of 9 is 3. 75, if you did a factor tree, is going to break down to 5, 5, and 3. The two 5s go together, and so it's 5 root 3. 27, 3, 3, and 3. Two of the 3's go together because that's a 9, right? So the square root of 9 is this 3 on the outside, 3 on the inside, okay? What do you do if there's already a number out there? So like this one, this example, right? There's a 5 on the outside. So when you break the 75 down, because it's only the stuff that's underneath the radical that we care about. So if you break that down, right, that's going to be a 5, 5, and 3. The square root of 5 is 25. And so that times the 5 that was already out there becomes that 25 square root of 3. Okay, so here's a couple more examples that you can see. I actually want to go through and do a couple of these for you. What you're going to be doing as proof that you followed along with this is you're going to be either typing in your work in here or you're going to be inserting that picture in here. If you wanted to get that radical sign, you have to go up here to where it says insert. You're going to insert a special character, and then you can start typing it in down here. So you can type in root, right, for square root, and then there's the square root symbol, okay? And you can just click on it, and it'll insert that square root symbol for you, okay? All right, so let's go ahead and do this first one. So let's do the square root of 8. So if I'm going to do the square root of 8, now again, some of you are going to be really good at finding those numbers that go into it. So if you are one of those people that are really, really good at finding that, I want you to show me that that's how your brain is working and figuring it out. Hey, look, I think I can find these numbers pretty quick, Miss Hunsaker, so just tell me that, okay? The square root of 8 is going to be 4 times 2, okay? And you know what the square root of 4 is. It's a 2. Okay, so I want to see this on your paper because that's just showing me what your brain is doing, okay? If finding that 4 is difficult, or not difficult, but just challenging for you. By the way, it's totally challenging for me. I mean, I'm just telling you right now. I have a hard time with them too. So make the factor tree, but show me that you're making the factor tree, okay? So 8 is going to break down to 4 and 2. 4 is going to break down to 2 and 2, and you want to break it down as far as possible. Okay, so the square root of 8 is going to become 3 of these 2's, okay? And then, right, you have to put pairs together. So the square root of 2 and the square root of 2 becomes the square root of 4, which is 2. So I don't know if you noticed my chicken scratch. I kind of circle my pairs, and then I'm like, ooh, the square root of 4, 2. Okay, so my final answer has a 2 on the outside and a 2 left on the inside, which is what we had before. Okay, let's go do the square root of 45. So the next one, square root of 45. Again, some of you might be really good at finding the numbers that go into it. That's great. If you're like me, just do a factor tree. Okay, so 45 is going to break down to 9 and 5. Doesn't matter how you break it down. What matters is that you break it all the way down. So if you did 45 as a 3 and 15, you're going to get the same answer when we're done. Okay, so let's see, 45, if I did 9 and 5, I'm going to get 3 and 3. And so when I put this back underneath, I have 2 3's and a 5. Notice that's what I had over here when I did 3 and 15. Okay. All right, and then same thing, right? We're going to put pairs together. So 3 times 3 is 9. The square root of 9 is 3. Okay, and so this answer becomes 3 root 5. Okay, I'm hoping that that's making a little bit of sense for you. I'm going to go do one more with you, and then you're going to do the rest of them on your own. So let's go do the square root of 50. Okay, so again, we're going to break it down, okay? I don't know, 5 and 10. Maybe you broke it down a different way. Again, we're going to get the same answer, okay? 10, 2 and 5, right? So the square root of 50, depending on what your factor tree looks like, the only thing that I do want to say, and I did this on purpose, But you definitely want to put the numbers that are the same together. So I'm going to put the 5s together. So 5, 5, and 2. Okay? Again, 5 times 5 is 25. The square root of 25 is 5. So this final answer is 5 root 2. You're going to go ahead and finish up T, O, S, and E on your own. Okay? When you get done with that, we're actually going to skip slide number 6, so you don't have to do slide 6. We're going to go talk about rationalizing the denominator. So the last little bit to do is rationalizing the denominator, okay? And here's what it means. Radicals are not allowed to be in the denominator. It's kind of like dividing by 0. It's against the math laws, okay? So we have to get rid of this root 2. You're going to multiply this number by 1. It's the only number you're allowed to multiply that's not going to change this number. So you're going to multiply it by what's actually in the denominator because that's going to make it go away. So watch how this works, okay? Notice I have a root 2 in the denominator, okay? So I'm going to go multiply by root 2 over root 2. Again, any number divided by itself is just a 1, okay? So this is root 2 over root 2. When you go to multiply, you're going to multiply the numerators together. So 5 times the square root of 2 is just 5 times the square root of 2. On the bottom, you're going to get the square root of 2 times the square root of 2, which is the square root of 4. And what's the square root of 4? 2. And check it out, there's no more radical sign. That is what is important. Let's go look at that again. Here's another example. 5 divided by root 10. Okay, the square root of 10 is not allowed to be there, so we have to multiply it. Do you see the green root 10 over root 10? So let's go multiply the numerators together. 5 root 10 is just 5 root 10. The square root of 10 and square root of 10 is the square root of 100, which is 10. Okay, now here's where you got to be a little bit careful. You can only reduce the numbers that are both on the outside. So the 5 and 10 can reduce to a 1/2. You can't reduce numbers if one is on the inside and one is on the outside. So just be careful about that, okay? Next example. All right, sorry about that interruption. So the next example, right, we have a 5 divided by 2 times root 7. Again, the root 7 is not allowed to be there. It's illegal, so we have to go get rid of that. So we're going to multiply by 1, okay? And we're going to multiply by root 7 over root 7. So when you multiply the numerators, 5 and root 7 is 5 root 7. When you multiply the denominators, you're going to get 2 times the square root of 7 and the square root of 7 become the square root of 49, which is 7. And so 2 times 7 makes 14. Okay? All right, let's take a look at this one, these examples. Keep in mind that it's the denominator that is illegal. So it doesn't matter what's in the numerator. It's the denominator. So you're going to be multiplying this fraction by root 5 over root 5. Okay? The square root of 7, square root of 5 is square root of 35. Root 5 becomes root 25, which is 5. This one, okay, same thing. You're going to multiply by that root 7 over root 7. Okay, so we get the square root of 21. The square root of 49, which is 7. Now keep in mind, one more time, right, you cannot simplify if one is under the house and one is out of the little radical house. Okay, you can only simplify them if they're together. All right, let's go do these last 2 examples. You're just going to, again, make sure that you're copying this down, hit, type it in, insert a picture, and hit submit. Okay, so let's go do 2 divided by root 3. All right, so again, we can't have a square root in the denominator, so we're going to multiply by 1. That means that my numerator and denominator have to be the same thing. So we're going to multiply by root 3 over root 3, root 3 over root 3. All right, 2 times root 3. Square root of 3 times the square root of 3 is going to become the square root of 9, which is 3. Done. That's it. Okay, next example. Square root of 11 divided by the square root of 5. Keep in mind it's the denominator that's not allowed to be there. So multiply by root 5 over root 5. This is going to become the square root of 55. Square root of 5 and square root of 5 is the square root of 25, which is 5. That's it. That's all there is to it. Go hit submit.